All right, today we're going to talk about piecewise functions. And let's start off with just a quick review of what we just finished talking about, and that's function notation. So we said for function notation, that's when you call a function like f of x or g of x. But basically, you have this equation part over here, this 3x minus 7, and that's what tells you what to do. Well, with a piecewise function, you might have more than one equation there. Maybe sometimes f of x equals 3x minus 7, but sometimes it equals something totally different, like 5x plus 1, or something like that. That's a piecewise function. Now here's an example of what one looks like. So you have f of x equals, just like you do in function notation, but then instead of having one equation, you have that curly bracket that groups together two or possibly more equations. So basically, this piecewise function right here is saying sometimes f of x equals 3x plus 4. And sometimes it equals x minus 1. Now, this part over here on the right, this tells you when to use each equation. So a good way to think of it, this is your if part. So that top one says x is greater than 1. Oh, I'm sorry, it says x is less than 1. So what we're really saying is if x is less than 1, then f of x equals that top equation, 3x plus 4. Now the bottom one says if x is greater than 1, then f of x equals that equation. So a piecewise function, it has more than one equation, and then it also tells you when to use each equation. And it's all about what x equals. So for example, in this problem, if I ask you to find f of 10, it means plug 10 in for x. But before you can do that, you have to figure out which equation to plug it in for. Do I take the top equation, 3x plus 4, and plug in 10? Or do I take the bottom one, the x minus 1, and plug in 10? Well, what you would do is you would look at the number 10, and you would say 10 is greater than 1. And for any number greater than or equal to 1, I use that equation there. So the answer to that question would actually be 9. I would plug in for 10 for x and get 10 minus 1, which is 9. We'll do a real example in just a second. But you get the idea. What you're doing is you're looking at this number right here, and then you're choosing one of these two things. You're saying, is that number less than 1? I use the top equation. Is that number greater than or equal to 1? I use the bottom equation. Then, once you pick the right equation, you still finish the question by plugging in that number for x. So here's our real example. Here's a piecewise function. It's actually the same one. And we're going to do 3 different problems. We're going to find f of 5, f of negative 5, and f of 1. So let's start with f of 5. The number is 5, and my choices, this is actually the same example we just did. My choices are, is 5 less than 1, or is 5 greater than or equal to 1? Now 5, just like the 10 before, is greater than or equal to 1. So what that means, the equation I'm going to use is the bottom one, x minus 1. Now once you figure that out, you still have to plug 5 in for x. So I get 5 minus 1, and my answer is 4. f of 5 equals 4. Let's try f of negative 5. And I'm going to start with f of x again. So I start with the negative 5, and I say this time I'm going to use the top equation because negative 5 is less than 1. So this time I'm using f of x equals 3x plus 4. And then I'm going to find f of negative 5 by plugging in negative 5 for x. And then we're going to finish it out just like we did on function notation day. 3 times negative 5 is negative 15. Negative 15 plus 4 is negative 11, and that's our answer. Let's do the last one, f of 1. Oops, it's not a very good color for this scheme. Now for this one, the number is 1. Now remember, my choices are, is 1 greater than 1? No. Is 1 less than or equal to 1? Yes. So that has the or equal to. 1 is equal to 1, so I'm going to use the bottom equation for this one, the x minus 1. And then I'm going to plug in 1 for x. 1 minus 1 is 0 for my final answer. So we did 3 different things. We found f of 5, we found f of negative 5, and we found f of 1. For each question, there were 2 parts. Part 1 is look at the number itself, the 5, the negative 5, or the 1, and decide which equation to use. Once you pick the right equation, plug that number in and get your answer, just like we did for function notation. I have one more quick example for you guys, because I did want you to see one that has 3 parts. This is a piecewise function that has 3 different parts. This says sometimes f of x equals 7x, sometimes it equals x plus 5, and sometimes it equals x squared. So let's find f of 4 and f of 5. And we'll do f of 4 first. So I'm going to write f of x equals just like I did last time, because the first thing I have to do is pick the right equation. Am I going to use the 7x, the x plus 5, or the x squared? So I look over here at my choices and I say my number right here is 4. My first choice, is 4 less than negative 3? No, it's not. So I'm not using the first equation. Okay, my second choice, now this thing right here in the middle, it says x is between negative 3 and 5. When you have x in between 2 numbers like that, that's a way of saying in between. It's saying negative 3 is less than or equal to x, which is less than 5. So what you're really asking is, if I put my number 4 there for x, is 4 in between negative 3 and 5? And yes, it is. So this looks like my right equation, x plus 5. Now before I do it, let's just check the last one. Make sure that you shouldn't be in 2 intervals at the same time. But my last one, if I try to 4, I ask myself, is 4 greater than or equal to 5? No, it's not. So we definitely have the right equation, x plus 5. Now what I'm finding here is f of 4. So I plug in 4 for x. 4 plus 5, very simple, 9. We got our answer. Okay, let's do the same thing for f of 5. So let's go through our choices again. Top choice, is 5 less than negative 3? No, it's not. Choice number 2, is 5 between negative 3 and 5? Well, it's right on the edge there. And when it's right on the edge, remember we just saw an example like this with the 1 in the last example. You're looking for the one that has the or equal to it. So this is the one we actually want. The last choice says, is x greater than or equal to 5? The answer is yes. Right here, if I just kind of focus on the second half of this, is x less than 5? Is 5 less than 5? No, 5 is not less than 5. But it is greater than or equal to 5. So whenever the number that you're testing actually matches one of the numbers from the piecewise function, it goes with the or equal to one. So for this one, I'm using x squared. And then I plug in 5 for x, and I get 5 squared. 5 squared, or 5 times 5, is 25. And that's my final answer. So that's what we're doing today. We're taking piecewise functions and we're using them. We're finding values just like we did for function notation, but there's an extra step on each question where you have to choose the correct equation from the piecewise function to use.